time, you guys are great. And if I can get 90% of the time out of you, I'm good. Okay, here we go. You know how to do this lesson. It's 8-2. It says multiplying polynomials. Well, you've already done this for the most part. If I said x to the third power, and I put parentheses and went x to the fourth power, what would you give me for an answer?
6.
Ooh.
X to the 7.
X to the 7th power. Remember, we add the exponents when our bases are matching, right? We add the exponents when our bases are matching. And so that's what we're doing today. But sometimes you're going to have more than one thing to multiply by. You're essentially using the distributive property multiple times. Of course, I love the distributive property, so I like this lesson. Anyway, I'm going to work the example. I'm going to cover it up so I can't see it. I think you do better when we kind of walk through it. You'll see that this is actually quite simple. It can get confusing. It's a tedious lesson, but it's not a difficult lesson. Mistakes are going to happen because you're in a hurry or you miss a sign. So let's start. If I have 3x times the 2x squared, what's 3 times 2?
6.
The 6.
X to the 3rd.
And it's going to become x to the 3rd power because I'm adding the exponents on the bases that are matching, right? Now let's move to the 8x. 3x times the 8x. Positive 24. How many x's?
2.
2. Good. And then 3x times a negative 1 is a negative 3x. Guess who's finished with their problem?
No.
Not bad, right? Do you not believe me? You're not trusting me?
No, I just thought you had to add one.
Okay, thank you for saying that. We now need to look at all of our exponents because there's a possibility we might have to combine terms. But remember, these guys all have to be the same for me to be able to add them together. Am I going to be able to do anything here? No, they all have different exponents, so it's no go. Try it on the right-hand side. Try it right here. What do you think? Check your work. If you made a mistake, let's find it and figure out why. Okay? You okay with this? Good? You totally messed up. Would you mind sharing what you did?
I didn't distribute. I grouped everything.
Okay, you grouped everything. No, we're going to take each thing separately. Okay? And then once we've done the distributive property, we've removed all of our parentheses. We're going back now and looking at our exponents. Do I have any exponents that are matching? No. Are they actually in good order?
Yes.
Yeah, so I'm actually finished with this problem. So we need to make sure they're in the proper order and that we've done good math. Okay? So be careful. The minus times the minus is going to be important. Okay? All right, let's try the next example. You good? Yeah, well, what? Talk to me.
So, how do you distribute negative 6 3?
Yes, ma'am. Okay, okay, right here and here. You're talking about this one to this one, right? Okay. The negative 6 times the negative 1 would be a positive 6. D to the 3rd times the D to the 1 makes a total of D to the 4. You okay? And a lot of students find it helpful to, before they even start their problem, honestly, they put a 1 wherever there's not an exponent on a variable, so they remember to add it to the problem. A lot of students lose the 1. So if that's something you need to do, that's a good idea. Okay? All right, let's look at the next. Anybody else? We're good? All right, let's look at the next example. Once again, I'm going to cover it up and work it, and you're going to work it with me. How is this one different than the one we just did?
It's got a negative x. We have to distribute it. Oh, that's this example.
I must be lost because I don't
I
see
was
it.
on the child.
Okay, my bad. Look at this example though. How is this different? Anything. There's two sets of distributing this time, right? Okay, we can do that. In the end though, if there's two sets of distributing, there's a really good likelihood I'm going to have to add or combine some like terms. All right, so let's see if that happens. So I'm going to go, okay, 2p times a negative 4p squared. So what's the number, what's the coefficient going to be?
3.
A negative 8. And I had a 1 there, so a total of p to the third. Then I'm going to do it again over here to the 5p. So it's going to be a negative 10p to the second. Now I'm taking this negative that's in front of the 5 and I'm attaching it. I'm going to go, okay, negative 5 distributed to these guys, it's going to become a, so this should have been a positive 10, sorry. Positive, positive, positive. This becomes a negative, and then negative times that is a negative 100. Now, do you see anybody who has matching exponents?
Yes.
So what do we have to do? Because they both have p squareds, we need to add them together. What is a positive 10 and a negative 10 going to do?
Cancel.
They're going to cancel out, right? Because they're opposites. So your final answer is going to be negative 8p to the third minus a 100. And that's your answer. We good? All right, see if you can do the try it on the right-hand side. Try not to make a mistake. Okay. Check your answer for that first row. Make sure you're good before you go any further. Are you okay? Okay. Order matters. Order matters. Combining like terms and order matters. So if order matters, let's start with the biggest exponent that you see.
3.
A 3. So that has to be out in front. Okay? So that is going to lead us off. I don't have any other x to the third powers. So now I'm moving to x to the second power. So I've got 15 that's there and a negative 2 that are here. What's 15 with added to a negative 2?
13.
A positive 13.
X equals
Things called x squared. Remember, it's just a label. It's just a label. It's just things. Now, do I have any x to the first powers? Yep, there's a 6, and there's a 3. So 3 plus 6 is 9 things that are called x. And then I have a minus 12. You good? Alright. Any questions on that one? Alright. Let's look at this third example. Not to try it, but the example. Alright. How is this different? It's got an equal sign. That means you got to wind up with a real deal answer, like y equals something. So we're going to have to work both sides, combine like terms, and try to get the variable by itself in the end. So we're going to work it like we would before. So distribute. Negative 2 times 2 is a negative 4 with a y. Negative 2 times the 7 is a negative 14. This negative 2 is not inside those parentheses. Don't you dare multiply it by anything. He just drops down, okay? Thank you.
Ooh.
No, I'm not going to give this to you. For those of you who are watching the notes, look what just came to my door. Yay, okay. Oops, oh well. Now there's the equal sign.
Somebody just get me that.
Uh-huh. And then 4 times the negative y is a negative 4y. And then 4 times the negative 3 is a negative 12. Just bring down the 4. He does not get multiplied, right? There's the wall. Please remember, simplify each side before you start crossing through the wall. Is there anything on the left-hand side that can be added together?
Negative 4y.
The negative 4y and the negative 2y. So what will that answer be? Very good, negative 6y. So negative 6y minus 14 equals, how about on the right-hand side? Yep, right there. So there's the negative 4y brought down, and that turns into a negative 8. Combining like terms, trying to get the y's together, I would add 4 to both sides, 4y. That becomes a negative 2y, so negative 2y minus 14 is equal to a negative 8. Adding 14 to both sides to try to get the y by itself, you get negative 2y is equal to 6. When you divide by the negative 2, you get y equals negative 3, and that's a great answer. So a lot of this you already know, yeah? No, yeah, that was bad. Most of you know this already. Okay, try it, and we're almost done. The try it, many people have failed, so be careful. And I want you to check your first row before you go any further. Actually, this very first thing right here.
2D.
1D
squared.
You guys who put a the guys who put a 2D, you might have a good idea to put a 1 here, because what's 1 times 1 is a 1, and then you add the exponents on the d's. So be very careful. Then multiplying to the 3, I get plus a 3d. Multiplying this, I get minus a d squared plus a 4d equals a 9d minus 144. Combining like terms before I start moving back and forth, these two d's, d squareds, are going to cancel each other out. I can add these two together to get a 7d. And when I add 9 to subtract 9 from both sides, I'm going to get a negative 2d is equal to a negative 144. So your final answer when you divide by the negative 2 is a positive 72 for your answer. Now, if you had put a 2d, this particular problem would have actually turned out you would have gotten the right answer. Only because they canceled each other out, so your mistake never became visible. Okay? Please be sure that if it's a variable times a variable, it's at that variable squared. Okay? Any questions? Pretty good so far? Alright, this story problem is worked out for you, and it's not a difficult problem, and actually common sense would have made more sense to me. But there's something in here that I want you to just recognize, and I want you to see if you can understand what they're talking about before I let you loose on your homework, okay? This person's going to rent a car, and they charge her a $75 fee. For the Monday through Friday days, the weekdays, they charge her $15 for every day. But if it's a weekend, she gets to pay a little bit extra, so she pays $20 for each day on the weekend. If Jenny is going to rent the car for 7 days, they're wanting you to use a W for those days that are weekdays. So that means Monday through Friday is represented with the letter W, right? Huh? What's that called?
5
5. Well, no. Just W represents the entire any weekday. All the weekdays together. Yeah, there would be 5 of them, and that's part of our thing here. Okay. But it says, what is the cost of her rental if 5 of the days were weekdays? 5 out of the 7. So she really is going to rent a car for the full 7 days. They're wanting you, not now, in a minute, okay? They're wanting you to write this equation using this W. Well, if the W is representing those 5 Monday through Friday days, does it make sense to you that 7 minus the W represents the weekend or not? 7 days are in the total week. And if I take those 7 days and subtract just the Monday through Friday days, that's how what's left over is just the Saturday, Sunday, weekend days. So this is how they're representing the weekend prices. That's the part I just wanted you to understand why it's there. Okay? After that, I think you're fine, because here it's showing, here's the flat fee. That flat fee plus the number of weekdays times $15 for each of those days, added to the number of weekend days times $20 for each of those days. And then you could finish the math and you'll be fine. I'm confident in your skills there. So start your assignment, and I want you to get to number 23 right now as soon as you can, because I have the answer up here, and I want to make sure you're correct. The reason I'm giving you the answer to 23 is it uses 2 variables instead of 1. And you're going to freak out.
What page?
Page 475. Here is the answer to number 23. Did you get it right already? Anybody worked a little bit ahead? Yeah? You did good? Awesome. Yes, ma'am. You need a book? Okay. There's one over here behind Corey.